Alright, so we are going to work on 2.3 composition of functions, and in this particular case I'm talking about a very specific and very special composition of functions. We are talking about a set of functions that are inverses of one another. And the idea behind this is pretty much what you would expect, that if you put in an x value into the first function, and then you use that output to go into the second function, you should get the original number back out if they are inverses. And I'm going to go ahead, we're going to practice. Some of these will be inverses, some of them will not. And we're going to work through them and you can kind of see how these work. The one cool thing about functions that are inverses is that they are commutative. And I want to point out that for composition of functions, these are the only ones that are commutative. Alright, so if I'm asked to find, we'll go with f with the circle g of x. Alright, so again, I'm going to start with my innermost first, so I'm going to have my 3x plus 6. That's my new x for this problem. So I'm going to have a 1/3, right? This is my new x, so this I can ignore, and then minus 2. So if we go ahead, I'm going to cancel out where I can. Here I have a 3, and I'm going to cancel that with a 3, right, this one here. And here I'm going to have a 2, because 6 divided by 3 is going to give me a 2. And this is going to become a 1. So when I go ahead and rewrite this, I'm going to have 1x plus 2 minus 2. Well, plus 2 minus 2 becomes a 0. And 1x is the same as an x. Well, that was my original value, right? That was the thing that I put in. Now, I want to show you that if you have an inverse, you can go either direction. So if I were to go g composed with f of x, right? I could go ahead and write that this way, and I should also still get my x back out of it. Alright, so in this case, I'm going to have my 1/3 x minus 2, and that becomes my new x going into the g. And now I'm going to have a 3, right? This is my x, right? My 3x plus 6. Where's my cursor? There we are. So that's going to be a plus 6. Alright, here I'm going to just go ahead and distribute through. I'm going to have a 3 over 3x. And then I'm going to have a minus 6 and a plus 6. These two go to 0. I have a 3 over 3, which is the same as a 1, and this will give me just a 1x or an x. So this is an inverse. These are inverse functions to one another, and if you have those, then they are commutative. Inverses are the only time you get commutativity with composition of functions. All right. So let's go ahead and take a look, see if this next one is going to be an inverse or not. All right, so let's go with, I'm going to go with f composed with g of x. So my 5x minus 30 becomes the input, and I have the 1/5, and that's my x, so this is in place of the x, minus 6. So I'm going to go ahead and I'm going to cancel where I can. I have a 5 over 5. That's going to give me a 1. And here I have a 5 going into negative 30. That's going to give me a 6. So when I rewrite this, right, and this is going to cancel out completely to be a 1. So when I rewrite this, I'm going to have, whoops, I want my purple color. I'm going to have 1x minus 6 minus 6. Now, on the surface of it, if you're not careful, if you're not paying attention, it'd be real easy to say, yes, this is an inverse. But the point is that it's not. You've got an x minus 12 here. All right. And if we were to do the g composed with f, we would get a different answer. We would not get the same answer. So, and that's a good way to double check. If you think, well, maybe I made a mistake, I want to go back and double check it. You can certainly do that. You can do the g composed with f of x, right? This whole thing. And so the f becomes the 1/5 x minus 6. And that's our new input into the g function, which is going to multiply by 5 and then minus 30. So here I'm going to have my 5 and my 5. That's going to cancel to a 1x, so that's going to give me an x. And then 5 times negative 6 is going to give me negative 30 minus 30. So this is going to give me an x minus 60. All right, so clearly these are not the same. And because they are not the same, we know that they cannot be inverses, even though we have one x out of the deal. We have other things that get attached to that, and that prevents it from being able to be an inverse. Remember, if you have an inverse, you're going to put in the x, and you're only going to get the x back out. All right, so let's take a look here. Let's go with this. Doesn't matter which way I go, we'll pick. This time let's go with the g composed with f, just because we've been doing the f composed with g first for a while now. Okay, so my f becomes my new input, right? That becomes the x here. So I'm going to have my 3 over 5, and then my x, I can leave a big old space here because I know I'm going to put this in. I just don't, you know, I maybe don't have it all written out yet. And then I'm going to have my minus 2. Actually, that's, nope, I want to do that. I'm kind of coming at this a little backwards. Sorry about that. So I'm going to have my, rewrite that. So I'm going to have my 3/5 x minus 2, and then this becomes the input. Sorry. This becomes the input. And then this is my 6 with my input. That x is my input. So this whole thing is that plus 10. All right, so I'm going to go 18 over 5 minus 12. There's an x there. I forgot my 18 over 5, 12. 18 over 5x minus 12 plus 10. Okay, and so right here you can see this is not going to go to 0. So it's pretty clear that this is not going to be an inverse function. Okay, so here I have my 3 3/5 x minus 2. So this is clearly not a case of an inverse. All right, I'm not going to bother with chasing it down the other way. Now I will say that you could have written this a little differently than what I did, which is I could have said, all right, I know my g is going to be my big function, right? So I'm going to do a 6, and then I'm going to leave a big old space, right, so that I can put in whatever my new x is going to be, minus or plus 10. So then I go back and take a look. Here's my f of x, and that becomes a 3 over 5x minus 2. And again, we get the same answer if we're going this particular route, I wanted to show you that there's two different ways you could have approached this. You could start with the f as the input and work out with the g of x, or you could write the g of x and then but leaving the space for the f of x to be put in. All right, so both of those methods work. And I'm actually going to stop at this point, and we'll come back and resume with more of our inverses. See if we can find any more of them.